So in this virtual session we will continue with chapter number 3 about data preprocessing. In face-to-face class we discussed the data preprocessing in overview with data quality and major tasks in data preprocessing, the data cleaning, and the different methods to resolve the problem of noisy data, of incorrect data, etc. So in this virtual session we will investigate data integration, data reduction, data transformation, and data discretization. So data integration, that means we want to combine data from multiple sources into a coherent store. And when we combine this data, we can, for example, make a schema integration. That means we have to detect that customer ID in table A is equivalent to cast hash in table B. Integrate metadata from different sources. Also, there is another problem, the entity identification problem. So we can find some real words that are different, but in text, but they represent the same data. For example, Bill Clinton and William Clinton. So also, when we make data integration, we have to detect and resolve data value conflicts. So for the same real world entity, attribute values from different sources are different. We can find, for example, distance in database A in kilometer, and distance in database B in miles, and with different representation, different scales, we can find value conflicts. Any questions about data integration? Are you here? Okay. So handling redundancy in data integration. One of the problems in data integration is the redundancy. So redundant data occur often when integration of multiple databases. So the same attribute or object may have different names in different databases. So in this case, we will obtain redundancy. So we have to identify this attribute and keep only one attribute. Also, derivable data can be or can represent a redundancy. So one attribute may be a derived attribute in another table, for example, annual revenue. So redundant attributes may be able to be detected by correlation analysis and covariance analysis. And in this session, we will learn how we can calculate correlation analysis, correlation value, and covariance value. So correlation value and covariance value give us an idea if there is a relation between two attributes. So correlation analysis for nominal data. Here we will talk about correlation analysis for nominal data. So we will calculate P square, P or Q square. So the formula of Q square, here nominal data we will treat only nominal data. Q square equals the sum of the observed minus expected square divided by expected. So the larger the K-square value, the more likely the variables are related. So the cells that contribute the most to K-square value are those whose actual count is very different from the expected count. So actual count, that means observed, and this is expected. So let's move to an example. So in this example, our task is to search if, like science fiction, is correlated or not to play. This is the question. We have two variables, like science fiction and play, and here we will also calculate not like science, not, and not play. Okay, so the value here 250 represents the observed value, and this value is the expected. That means we find that 250 tuples like science fiction and play chess. It's clear? Are you here? Okay, so after that, when we want to calculate K-square, we just make 250 minus 90 square divided by 90 plus 50 minus 210, etc. So we will obtain this value. So this value shows that like science fiction and play chess are correlated in group. So we use K-square calculation, and with K-square calculation we find that two attributes or two variables are correlated. So in our task, in the integration data, we can remove play or remove like science fiction. We can remove one of these attributes. Any questions? It's clear how we can calculate the correlation? The first one or the second, because there is a redundancy between the first and the second. So here we keep in the mind that we calculate K-square to detect a correlation between attributes. Okay, so here we have one attribute, attribute 1, attribute 2, and here we can find play, like science, not play, not like science, not play like science, etc. So we want to calculate the correlation between these attributes, attribute number 1 and attribute number 2. So here, for example, the first tuple, play like science. So we will add +1. So after that, here also another tuple 2. After that, here also another tuple 3. After calculation, we find that 250 tuples like science and play. It's clear, Ahmed? We will also calculate the number of like science and not play, not like science and play, not like and not play. After that, we calculate K square, and we find that K square is very large here, is more than 8. For this reason, we can say that like science fiction and play are correlated. So that means attribute 1 and attribute 2 are correlated. So we can, as a pre-processing task, we can, for example, eliminate attribute 1 or eliminate attribute 2. It's clear now? Let's move now to correlation analysis for numeric data. So for numeric data, we can calculate correlation coefficient RAB equal the sum of AI multiplied by BI minus N multiplied by the mean of A multiplied by the mean of B divided by N minus 1 multiplied by the standard deviation of A multiplied by the standard deviation of B. So N here is the number of tuples. A and B are the respective means of A and B, and sigma A and sigma B are the respective standard deviation of A and B. So if we find RAB more than 0, so A and B are positively correlated. So what's the meaning of positively correlated? That means if the value of A increases, so the value of B increases also. So if RAB equals 0, that means independent, and if RAB is less than 0, so that means A and B are negatively correlated. That means if A decreases, B also decreases. It's clear? Any question? Let's move now to covariance. So covariance, the formula of the covariance is the mean of A minus mean A multiplied by B minus mean B. So there is a relation between the covariance and the correlance. So the correlance equal covariance divided by standard deviation of A multiplied by standard deviation of B. So if we have positive covariance, that means A and B tend to be larger than their expected values. And if we have negative covariance, that means if A is larger than expected values, then B is likely to be smaller than its expected value. And independence, that means the covariance between A and B equal 0. So there is another formula for covariance A and B, this one. So the covariance of A and B equals the mean of A multiplied by B minus the mean of A multiplied by the mean of B. Let's get an example. So please, your attention please for this example. Suppose two stocks of A and B have the following values in 1 week. So the first one A, B, etc. So question, if the stocks are affected by the same industry trends, will their price rise or fall together? So here, to respond to this question, we have to calculate the covariance. So let's begin with the mean of A. So the mean of A is calculated based on the value of A. We have here 2 plus 3 plus 5 plus 4 plus 6 divided by 5. It's clear why the mean of A equals 4? Okay. After that, we will also calculate in the same way, the mean of the B. 5 plus 8 plus 10 plus 11 plus 14 divided by 5. We will obtain 9.6. After that, we will calculate the mean of A multiplied by B. So we will make 2 multiplied by 5 plus 3 multiplied by 8 plus 5 multiplied by 10 plus 4 multiplied by 11 plus 6 multiplied by 14, and after that divided by 5. So this part represents the mean of A multiplied by B minus the mean of A multiplied by the mean of B. So the covariance of A and B is more than 0. So for this reason, A and B rise together. A and B rise together. Any questions about covariance? It's clear how we can calculate covariance. It's very easy. Not 5, not minus 4. Yes, this is A, the mean of A implies B. This one minus, this one minus. After that, 4 represents the mean of A, and B. 9.6 represents the mean of B. It's clear, Ahmed? Okay. Any questions? Okay. Let's move now to data reduction. So, data reduction, we want to obtain a reduced representation of the data set that is much smaller in volume but yet produces the same analytical results. So why we want to reduce the data? So a database or data warehouse may store terabytes of data, and complex data analysis may take a very long time to run to the complete data set. So there are many strategies to make data reduction. We can find the first category is dimensionality reduction. The second one is numerosity reduction or data reduction. And the third one is data compression. So in dimensionality reduction, we can find wavelet transform, principal compounds analysis, and feature subset selection and feature creation. So for wavelet transform decomposes a signal onto a different frequency subbands. It is applicable to n-dimensional signals. So the data are transformed to preserve relative distances between objects at different level of resolution. So this one is the first level. We divided the image by 4. This one is the second level, first level, second level, etc. So wavelet allow natural clusters to become more distinguishable and are used for image compression. The second strategy is PCA. So PCA fund a projection that captures the large amount of variation in data. So when we use PCA, we have original data, and this data are projected onto a much smaller space. For this reason, we talk about reduction, resulting in dimensionality reduction. So we find the eigenvectors when we use PCA. We find eigenvectors of the covariance matrix, and these eigenvectors define the new space. So for example, we have here a space with 2 dimensions, x1 and x2, and when we use PCA, we will use only 1 dimension, E in our case. Any questions? Let's move now to attribute subset selection. So let's suppose that we have a data record with attribute 1, attribute 2, attribute 3, attribute 4, attribute 5. So what's the meaning of attribute subset selection? Can you explain me what does mean attribute subset selection? So attribute subset selection, that means we will select a subset. For example, we will select attribute 1 and attribute 3. Yes, not all. Or attribute 1, 3, and 5. Yes. So why we select? We will select some attributes because we can find redundant attributes. So duplicate, match, or all of the information contained in one or more other attributes. We can find also irrelevant attributes. So irrelevant attributes contain no information that is useful for the data mining task. For example, the student ID is often irrelevant to the task of predicting students' GPA. So ID must be removed. So how we can find or select the pertinent attributes, the relevant attributes? So there are two the possible attributes combination of the attributes. For example, if we have 4 attributes, there are 16 possible attribute combination. So we can use many manners or strategies to select relevant attributes. For example, we can use best stepwise feature selection. So we prepare هذا الظرف. After that, we will search the best single attribute. In other words, if we want to make, for example, classification using only the attribute 1 or only the attribute 2 or only the attribute 3, what is the best single attribute? Let's suppose that attribute 3 is the best single. So we will keep attribute number 3, and after that we will search. No problem, Mr. Abdulaziz. After that we will search what is the next best attribute condition to the first. That means what is the second attribute combined with attribute number 3 give us the best performance. For example, attribute 1. After that we will search what is the attribute added to attribute 3 plus attribute 1 give us the best performance. For example, attribute 4, etc. Okay, Mr. Nabil, if there is a problem, it is a problem in Blackboard. So يعني يكفي انه يبعثوا لي ايميل ويقولوا لي انه في problem في البلاكبورد. ما في مشكلة. You are welcome. It's clear the best stepwise feature selection. This method, it's clear for you. Any questions about this method? Okay. Number of words, percentage of violent words, percentage of image, etc. Class, violent, non-violent, violent, etc. And here we have some values. Let's suppose that we have this record data. Okay, so our task is to find what is the subset of attributes, or the best subset of attributes. So we will use only the number of words to calculate the class. Okay, Ahmed? Only the number of words. After that, we will calculate accuracy rate. For example, we find that the accuracy rate is 40%. We will see what's the meaning of accuracy rate. But let's suppose that accuracy rate, that means our classifier can predict the correct class in 40% cases. Only the percentage of violent words, 50%. Okay. Only the percentage of image, 20%, etc. After that, so the best single attribute used to make classification is the percentage or frequency of violent word. Okay, so we keep the best attribute. We will save it. This is our first attribute. After that, we will search what is the best second attribute. Added to this first attribute can classify or can give us more than 50%. So we will test the percentage of violent word and all words together. For example, give us 60%. And we will test also the percentage of a violent word with the percentage of image. We give us 70%. So the attribute number 2 will be the percentage of image, etc. So in this manner, we will select, in each iteration, we will select the best attribute. Okay, no problem. The best attribute added to the first one, after that to the first plus the second, after that to the first, second, and third, etc. It's clear, Ahmed? Okay. So the second manner is to eliminate the worst attribute. Eliminate the worst attribute. So in the first iteration, we will eliminate the worst attribute. After that, we will obtain, if we have n attributes, we will obtain in the first iteration n-1 attributes. After that, we will eliminate another attribute. We will obtain n-2, etc. So there are many manners to make or to search the best attributes. Attribute creation. So we can create a new attribute, then can capture the important information in a data set more effectively than the original ones. And there are 3 general methodologies. The first one is attribute extraction. The second one is mapping data to new space. The third one is attribute construction. So for numerosity reduction, that means we will reduce data volume. by choosing alternative smaller forms of data representation. So there are parametric methods. So in numericity reduction, there are parametric methods and non-parametric methods. So for parametric methods, assume the data fits some model, estimate the model parameters, and store only the parameters and discard the data. For example, we have many data like this, and after that we will create a log linear model. So we will just save the equation of this model. Non-parametric method do not assume models. We can use histograms, clustering, sampling, etc. So in parametric data reduction, we can find linear regression. So data modeled to fit a straight line often uses the least square method to fit the line. For this reason, we talk about linear regression. Multiple regression. Allows a response variable y to be modeled as a linear function of multidimensional feature vector, and log linear model approximate discrete multidimensional probability distribution. For histogram analysis, let's recall that histograms is non-parametric method. Histogram is non-parametric method, and it is used to reduce the data volume. So for histograms, we will divide into buckets and storage average for each. So there are many manners to make the partition of this buckets. For example, equal width or equal frequency, etc. Sorry, regression. Here, regression. But I remove the slide of regression in here, just here. Yes. So there are some details. I cannot cover all the details. For this reason, I removed some slides. So for you, you have to keep in the mind that parametric methods or regression, and in the regression we can find linear regression, multiple regression, log linear models. And if you want to get more details about this regression, you can find these details in the slides or in the textbook. So clustering can be used to reduce the data. So partition data set into clusters based on similarity and store cluster representation. So can be very effective if data is clustered, but not if data is smeared. So can have hierarchical clustering and be stored in multidimensional index tree structures. So we will see all these details when we will discuss the clustering in chapter 5 or 6. Another manner to reduce data volume is sampling. So there are 4 types of sampling: sample random sampling, sampling without replacement, sampling with replacement, and stratified sampling. So we discussed all these types of sampling in the previous virtual session. Data compression. So normally you have an idea about data compression. So let's move now to data transformation and data discretization. So data transformation is a function that maps the entire set of values, so maps the entire set of values of a given attribute to a new set of replacement values. So each old value can be identified with one of the new values. So why we make this data transformation? Just I will prepare you a simple example. For example, we have Ahmed, Ali, and Muhammad, and here salary, age, experience. So here, for example, 1,000, 20, 120, 30, 1, 4. Okay. So if we calculate a Euclidean distance between Ahmed and Ali and Ahmed and Muhammad, we will find that Euclidean distance between Ahmed and Muhammad is less than Euclidean distance between Ahmed and Ali. But in the real world, Ahmed and Ali are more similar. So in this case, we have to normalize data. How we can normalize data? We can, for example, make salary divided by 1,000 and age divided by 10. Okay? Not split table, just we will normalize data. So the salary will be 1020, 1001. After that, the age will be 223, and the experience 114. To give all the attributes the same scale. After that, we can calculate distance, and we will obtain, or we will remark that Ahmed and Ali are more similar than Ahmed and Muhammad. So for this reason, we have to make normalization in our data. So normally here the function maps the entire set of values, so the set of values to a new set of values. So in my example here, the old values of salary are 1,000, 1,020, 1,001. The new values are 1020 and 1001. It's clear what's the meaning of here of transformation? It's clear for you what's the meaning of? Okay. After that, for normalization, we can find many manners to make normalization. For example, min-max normalization. The new value will be the value minus mean divided by max minus mean multiplied by new max minus new mean plus new mean. Let's get an example. So for example, we have income range between these values, and we want that all income range will be normalized to be in interval 0, 1. So for example, this value will be the same value minus the mean. So the mean in our case is 12,000. Okay, divided by max, this is the max, minus mean, multiplied by, this is the new mean, 0. This one is the new max, 1, plus new mean, 0. So we will obtain 0.716. So the first value is 73,000 will be mapped in 0.716. So it's clear how we can calculate a new value using min-max normalization. Yes, the value is, it is an example, just an example. I will prepare another example. For example, we have this example, all the values between 10 and 100. And we want that all this value will be between 0 and 1. Okay? So give me an example of a value here in this interval. For example, 54. So the new value will be 54 minus the mean. Our mean is, this is mean max. This is the new mean, new max. So mean 54 minus the mean. The mean is 10 divided by the max 100 minus mean 10 plus multiplied by new max 1 minus new mean 0 plus new mean 0. Equal 44 divided by 90. It's clear, Ahmed? Okay. Yes. So the second manner is Z-score normalization. This is the formula, and this one is an example. The third manner, normalization by decimal scaling. So the new value of V is equal V divided by 10 power G, where G is the smallest integer, such as the max of V is less than 1. So for example, in my case, if I use this normalization, So in my case, if I use this normalization, for example, I have this value 100, 5, 3, 1200. So the new value equal V divided by 10 power G with G. So what is the max here? The max. This is the max. Okay. So I have to make 102,000 divided by 10 power g, and it must be less than 1. So g in this case, so 2 100, 3 1000, 4 must be 4. But because if g equal 3, the value will be 1200 divided by 1000, it's equal 1.2. It is not less than 1. For this reason, we have to use the smallest g equal 4, not 5 or 6, the smallest. Yes, g here. Here, g must be the smallest integer, such as max of the new value is less than 1. So the max of the new value is 1200 divided by 1000. Okay.